So today we are going to kick off with our first and foundational question. What exactly is C Sharp? Well, my friends, the quick one-liner answer could be that C Sharp is a modern, object-oriented, type-safe programming language developed by Microsoft, which is pretty good response. But in order to actually understand, we need to go to a little bit detail. See, think about it like you are meeting someone for the first time. You get their name, but you want to know their personality, their history, what makes them interesting or boring. So let's try to understand a little bit history behind the C Sharp. Now, let's start with its DNA. C Sharp was developed by Microsoft, mainly led by these three gentlemen. Now, if you look at the evolution of C Sharp as well as the .NET framework, the 1.0, which was initially the first time .NET came in the market in 2002, then in 2005 they came up with C Sharp 2.0. Between 2005 and 2015, I mean there have been numerous the different uh, releases which I haven't put it here. In 2015 they came up with .NET Core, and that was one of the major release came which put it actually a solid foundational of the platform independent. What I'm hearing that in November 2025 this year, C Sharp 14 is coming out with .NET 10. So that's the whole the evolution. I mean how C Sharp evolved started in 2002 till now. Now the design actually, the C Sharp design actually takes inspiration from some of the existing languages, Java, C++, and even the Visual Basic. And aim was to combine the best features of all these different languages and create truly versatile language. But the takeaway here is that C Sharp was designed to be a modern language from the ground up, built for productivity. Now let's break down the core characteristics that define C Sharp. So I'm not going to talk in very detail what are the key features, because in next question we are going to cover about it. But at a high level, it's object oriented programming. It's the type safe, which having both strongly typed as well as the type safe the features, uh, being as very powerful, but at the same time the syntax is incredibly the easy to understand, is straightforward compared to some older languages. And since we are talking about the C Sharp, there is no way we can not talk about .NET. So C Sharp is the primary language for building application on the .NET platform. The .NET platform provides a massive library. Basically, think about it that it's a huge toolbox for pre-built code for almost anything you can imagine. For example, handling files, input, output, working on the networking features, building web API, and the CLR, which you see here actually on this, on the center part within the circle. This is the main, the heart which actually handles the execution. So the tight integration is what makes C Sharp so incredible, powerful, and versatile. It means that C Sharp applications, especially with modern .NET, can run on many different systems. It can run on Windows, Linux, Mac, mobile devices, and even on the cloud. So this cross-platform capability is a huge advantage for developers today. Now, since we are talking about that it is so powerful, so where C Sharp stands actually, it's actually everywhere. Uh, It's in web development, it's desktop applications. You can actually develop the game as well. I mean, nobody could have imagined that C Sharp would do such better in game, but a massive player here actually. Unity, one of the world's most popular game engine, uses C Sharp as its scripting language. Cloud computing, mobile development, the machine learning. So long story short, right? I mean, so let's wrap it up, guys. I believe we touched based most of the exciting things related with C Sharp, and let's define this again. What exactly is C Sharp? So it is not just a language; it is a powerful, evolving, object-oriented, and type-safe language tightly integrated with the .NET platform, enabling you to build almost any type of application you can imagine. So it's fantastic choice for modern software development. The question which we are going to cover it, what are the key features of C Sharp? In previous episode, I actually touched base what exactly is the C Sharp as a language, and in this episode we are going to cover the features of C Sharp which make this as a remarkable language, which most of the developers like it. And once again, I mean, the theme of this series, as you know, that it is a deep dive series. So I am not going to just cover one or two one-liner answer. Rather than the objective and the theme of this series is to go in a detail. So you don't have to memorize it. Rather, you can understand the concepts, and therefore it doesn't matter if interviewer expects one liner, you will be able to do that, but at the same time you will be able to clearly explain the concepts behind it, the reasoning behind it. You will be able to explain what, along with how, when as well. So let's dive in right away. Understanding C Sharp core characteristics is not just about memorizing a list, it's about grasping that why C Sharp is designed the way it is. So whatever, I mean, you see the features here, it's just not the fascinating words. There has been the real intention that why C Sharp has been designed with these features. So let's dive into all these features in detail. The first thing is that C Sharp is object-oriented programming. This means it organizes software design around objects rather than just functions. It allows us to model real-world entities and their behaviors in our code. And the main C Sharp core principles of OOPS, which is encapsulation, inheritance, polymorphism, and abstraction along with the composition, C Sharp fully supports it. Now, one thing I want to clarify here, that in this episode, we are not going into the deep details of these OOP principles. We have dedicated 20 questions, entire 2 modules, starting from question number 20 till the 40, and we will cover every small details about the OOPS, and we will go in very detail. We will open the Visual Studio editor and we will go with real the samples of the code, and I will explain each and every small concepts behind the OOPS, and I can guarantee you that, I mean, you will be able to understand all these concepts. But coming back to this episode, which is about C Sharp features, right now I think it is enough to understand that C Sharp fully supports OOPS, and it supports all the features related with the OOPS concept. Now coming back to another thing, which is the type safe. C Sharp is a type safe language. What actually it means that it is a strongly typed. Every variable and object must have a defined type. And what actually it means that compiler strictly checks for the type compatibility when you write the code. and it gives the error. Now, what advantage it provides? So it prevents common errors, assigning a string variable into the integer, just like, if you see the sample on this screen. So most of, these, the problems get resolved because it is a type safe language. Now, moving to next, the very rich collection of library. So C# is having a huge, the collection of libraries. It leverages the vast and comprehensive .NET Class library, which provides an extensive collection of pre-built functions and types. What exactly is the library? If maybe, I mean, someone who is uh, not very who has not used, all these libraries. So the whole idea is that C# is having the pre-built code, uh, which comes as a library which you can reutilize it to do your stuff. So let's say, regardless, I mean, if you are working on the networking or any security parts, authentication, authorization, you name it, right? The file processing, anything, any portion, any area, if you are coding it, you can utilize this library. Now, there are two very important, the features which I want to mention here, that platform independent as well as automatic garbage collection. So with the .NET Core introduction, which happened in 2015, C# is a kind of language which is a platform independent. What actually it means that the code which you write it, you can execute on Windows, Linux, or Mac, as well as the mobile devices or the cloud platform. Another very important feature is automatic garbage collection. In other words, what actually it does, that it frees the pain from the developers to actually go ahead and, the whole memory management thing, which in some of the languages you do through the coding. So it does the automatic, the memory management through the garbage collection, and therefore the developers can focus on, the main part, which is actually development or coding, rather than actually worried about that, the memory leaks, or all, the nitty and gritty things about the, the whole the memory stuff. Now, this is a very scalable and updatable programming language. What actually it means, that the language has been built uh, with keeping in mind that it can grow with the demand, handling everything from small utilities to large enterprise systems, web services, and cloud, the native applications. At the same time, C# is, extremely fast. The language is designed for, the high performance, with both its compilation and execution times, being remarkably, the quick. Now, coming back to, once again, I mean, to see these, the multiple features, many features which C# provides. For example, I mean, it's a very modern language. What actually it means, that it's constantly evolving, and that should be, the first thing the these days any, the modern languages should provide it, because, the things are changing every, the very, the with fast pace, and therefore Microsoft has been actually, it has been on the forefront. It has been, the releasing, the new upgrades, new feature constantly, and there has been constantly, the improvements, and that is why it is a modern language. I mean, if you see the entire evolution of C#, which I covered actually in my previous episode, they introduced C# in 2000, the two. But if you see all these new features, whenever, I mean, there is a need, they have been constantly, they improving this language. Another thing is, it's pretty simple language. When I say simple, what actually it means, that it offers a clean syntax and making it relatively very easy to learn. If anybody who is, has very little experience or no experience, it's pretty easy to, to start coding in C Sharp. So now, coming back to, just as a conclusion, C Sharp is, obviously robust, and the modern language built on this, powerful combination of all these features. So let's say somebody asks this question in an interview, right? Now, obviously, I mean, you can define the answer based on my previous question as well as this question. But one suggestion from my side would be that keep these, the three-step approach. That how, if somebody asks you what are C Sharp, what are the features, what C Sharp provides, how you will give the answer. So obviously, I mean, there are a ton of features here. Try to memorize two or three main points, and don't just try to give the definition which you memorize it. Explain in your way. So explain why it is beneficial for development and application building, and why, because this shows your understanding. uh, Once again, I mean, coming back to when you are trying to explain it, try to explain the what along with why, when, and how. So that gives an impression to interview that you not only memorize the things, but you actually do understand the concept. So that being said, that brings us to the end of our deep dive into the key features of C Sharp. I hope this episode has shed light on what makes C Sharp such a powerful and versatile language for building a wide array of applications. In our next episode, we are going to cover one of the very important and very frequently asked question, that what is the difference between value types and reference types. Today, we are diving into one of the very interesting and frequently asked question: what is the difference between value types and reference types? This is not just an interview question, guys. It is a core concept that explains how your C Sharp applications manage memory and perform. Whether you are a complete beginner or looking to solidify your advanced understanding, we are going to start from the absolute basics and going all the way to the low level memory implications. Uh, this episode can be a little bit longer, but I request you that please bear with me. We are going to start with some basic fundamental concepts. We will try to understand what is the value type, reference type. We will go through some basic definitions. Uh, we will try to understand the concepts, and then finally, I have probably 7 8 different, the code set which we will review, and we will open the Visual Studio Editor, and we will try to understand that what is value type, what is reference type, which variable goes at what place. So let's start. uh, we will start with pretty fundamental definition. So in C Sharp, every variable which we declare fall into one of these two categories. On the left, we have value types. As the name suggests, a value type directly contains its data. Think of it like a physical box holding a specific number, a character, or a true-false statement. When you declare a value type variable, its memory location is where the actual value is stored. When you assign one value type variable to another one, you get the complete copy of that data. So I mean, in simple term, value type is something like, you have something like physical copy. Okay. On the right hand side, we have reference type. So these are fundamentally different. Reference type variable doesn't directly contain the data. Instead, it contains a reference, essentially a memory address. Now, in value type, in this diagram, if you take a look, we have a box, and within the box, there is a 42 number. So 42 is a data, right? So that box, yellow box, actually a representation of a memory block where the actual data is stored. However, if you take a look the reference side, we have two boxes. In the first box, you have a arrow which is pointing to another box. So that is why we call it as a reference type. In reference type, what happens that data is actually stored somewhere else, and we will talk about that where the data is stored. But reference type is that it is actually a pointer which is pointing to um, something else. I'm not sure, I mean, how many of you have already coded and worked on in C++ in past. If you have, so you might be already familiar with this concept, the pointer. So reference type is pretty similar, the same thing. And that is why in C Sharp, right? I mean, by definition, we call it as value semantics, right? So what happens that in value type, when like I said earlier, when you copy one variable to another, you get a new copy. So it's like, think about it like if you are actually holding a physical book on your hand, and if let's say somebody else like that book, you actually prepared another copy and give it to him. So you have one copy and other person is having another copy. And let's say, I mean, the other person writes some notes on his copy, in other words, his book. Obviously, it is not going to reflect on your book because now you both are holding two different set of copy, right? A reference type, I mean, how I should give a explanation. Think about it, that same book, the scenario that the book is stored in library, right? And the other two-person, you both are having, the library card actually, where you can use your card and you can go and you can take a look at that same book. And then another person is also having a library card, and he can also go and take a look at the same book. Ultimately, you both are actually referring the same object, the same book, the same copy. Now, at a basic level, we understand now that what is the value type, what is the reference type. Now, in order to completely understand the value type and reference type, we need to understand the philosophy that why the value type, why reference type, and what relationship it has got with the stack and heap, right? Until unless we don't understand what is a stack and heap, we will not be able to understand what is the value type and what is the reference. So let's spend some time to understand what exactly is the stack and what exactly is the heap. So a stack is like a neatly organized stack of plates. It's a contiguous block of memory. Contiguous means, the all the memory, the blocks uh, is in the series, right? And it is fast. It's used for the local variables and method call information. So when a method is called, a frame is pushed onto the stack containing its local variable, and the moment method completes, the frame is popped off and the memory is instantly, I mean, you get free, right? So so this is where the stack is where your actually value types reside. For example, I mean, in this case, if you see int a equal to 5, the variable a and its value 5 are actually on the stack. The heap, if it is kind of, the large disorganized warehouse. uh, it is a reason of memory used for, the dynamic memory allocation, and where objects can live for longer duration, and it is independent of method calls. So when you use the new keyword to create an instance of a class, for example, I mean in this picture, if you see the person p equal to new person, the moment object is getting created, the data, the actual person object, the actual person data is actually gets stored on the heap itself. So, and string name equal to j, I mean the same thing, that uh, the data would be stored on the heap. Now, theoretically, I mean, we did talked about it, right? But the $1 million question is that why, what the heck is, I mean, why Microsoft came up with this, the stack and heap, these two memory model, the approach for a, the .NET, for the .NET platform. So I would try to, explain this concept with a pretty simple, day-to-day life activity, which we do, which happens in our house, right? So stack is like, it's like kitchen countertop. Think about it that you have got a small space. So stack is like a countertop, which is a small space, but it is very fast to access it. It's very fast to do your stuff, to do the temporary task, like chopping a vegetable, placing in, the ball. When you are done with something, you clear the space quickly, right? And you start doing another things. Once that is done, you clear it. So each time you are kind of, you are popping a stack frame, right? You are reclaiming the memory and you are going for another one. So it just like the, the kitchen countertop, stack also does the same thing. You use it, for your local variables, and once it is done, you free up the memory. What exactly is the heap? Heap is like, your kitchen pantry, where the objective is to store your big and, the longer duration items until it is expired, right? I mean, if something got expired in your kitchen pantry, what do? You throw it out, right? So same thing, right? uh, but it is not as fast as the stack. Why? Because, to go to the pantry, bring the stuff from there, obviously, from your kitchen place, right? You go, you walk there, you go inside your kitchen, the pantry, then you take a look, you do not know which stuff is there, right? So you locate it, you try to find it out, right? And then you use it. So there is an overhead involved. So that's exactly the same way stack and the heap works uh, when a .NET program runs. Now, in addition of that stack and heap, I wanted to point it out a few other things as well. Uh, Pretty soon, I mean, we are going to cover the code as well, and we will actually see which thing gets stored where, right? But apart from the stack and heap, these are the not only two things. And one thing actually I pointed it out, stack and heap, ultimately it is the same RAM. Okay, you got a machine, you have a RAM, right? The same RAM is divided between, the stack and heap. And as per my understanding, I believe what happens that on the Windows platform, normally by default each thread, normally stack, right? Stack gets 1 MB space. On Linux machine, I think by default it is 8 MB. You can change that. Yeah? I mean, it is a by default variable. When you do, let's say you create another thread, there you can specify that. I mean, you want to have this MB, but by default, normally on Windows platforms, it's 1 MB, and heap is obviously it is a dynamic allocation, right? So it can keep increasing. Uh, but let's say, I mean, this program .NET, the runtime engine is how it is going to allocate the memory. Obviously, the first portion is, the operating system and uh, the system, the OS and .NET runtime. the whole thing occupies some space, then you will have the code segment where the code which you write, like main and all that things, right? It goes under the code segment. Compile instructions, where the compiled code, gets their data segment. And a static counter is the place where you have static variables. All those will go into a static counter. And obviously then you have got stack and then heap. In this example, I mean, a is local variable, so a goes into a stack. Name is a string, which is reference type. So the actual data, which is a jar, that will go inside the heap. But the pointer, right, the reference, that actually will go to the stack. The same thing goes for the person class, where the data, right, let's say if you have the name and some other things, height and all that things, color, if you have all those, the different data, so entire the data will be stored on the heap. But the reference would go on the uh, stack. Now uh, obviously, I mean, we wanted to focus on the stack and heap for this question, but I just wanted to point it out that these are the other memory portion uh, as well, where memory gets allocated when you run a C# program. Quickly, we will take a look, just, the logical presentation. I know these numbers are pretty off, because the most of the time, right, except operating system, and .NET runtime and all other things, right, most of the space gets allocated for the heap as well, because this is where you actually store, the large and complex objects, and for the long live objects, right. Stack normally is having pretty, the small space, like I explained, that it is 1 MB by default for a thread. If you obviously create multiple threads explicitly, or you use like async and all that things, right, so internally it end up creating, not only the default thread but other threads as well. And in that case, you can have, the multiple, a little bit more space. Now, having said that, now I think we have fundamentally established what is the stack and what is the heap. Now, we will try to actually go through the code portion, and we will do some, the experiment, and we will try to see. We will go a little bit more deep dive. So let me go to my, the Visual Studio Code, and I will start with, let me see, I think I have some of the files I have hidden it. What I will do, let me enable all these. Okay, so let's take a look this one. We will start with example one.cs. Pretty simple code, right? I mean, one small, uh, the main function, and we have these, the two local variables created, num1 and num2. Uh, on line number 18, we are starting with the, the declaring and assigning num1. Obviously, the way the program is going to run, the first thing what actually it's going to do, that on line number 15 it will find out that it is a main method, so it's going to allocate it's going to create one, the main uh, uh, main, the stack frame. Within that, it's going to allocate num1, and right away, since it is, getting stored on the stack, it's going to put, num1 equal to 5. Let me do one thing. I should have one actually the pick for the allocation, and we can take a look. Yeah, here we go. So let's take a look. So uh we have got stack, we have got memory, we have got stack, we have got heap. In this program there would be no heap allocation, so that is why heap is empty. So we are inside the stack, and within that stack we have mainframe. This we are talking about uh, wait a minute, let me try to do one thing. Okay, so this mainframe we are talking about, this mainframe is this one. Uh, this main method, it is creating a main stack frame, and then all the local variables, right? All the local variable, primitive data types, everything was going to be stored here itself. Um, so num1, we got num1 variable. It is started with number 5. Then we have another num2 again, the value type. So it will have their own space. This one is nothing but the hexadecimal code of the the storage location. The same thing here. Since these two variables are going to be stored on the stack, so both will have their own location. To start with, num1 equal to 5. This will have the 5 initially. Then we have num2 equal to num1. What actually it means that this will have 5 as well. Now like I said, I mean, in the definition, that if you copy, right, a value type, if you assign it, you get a different copy, right? So that another value would be created. I mean, this is that copy, this is the second copy. So now both copies having 5 and 5, both copy is having, I mean, 18 19, you have 5 and 5. Now what we are doing here, num1 equal to 10. So what actually it means that here we are changing the value from 5 to 10. Now obviously if you see by this memory representation, these are the two separate boxes. We are changing num1 equal to 10. So this, I mean, this 5 would go away. We will have 10 here. But obviously these are the two different boxes. There would be no impact on this. If you run this program, obviously what is going to happen? I mean, you print it out, you will have uh, sorry, you will have num1 and num2. Obviously you will see two different values because these are the two different boxes. Okay, now let's quickly move to example 2. So let's see in example 2 what is going on here. So same thing, I mean, example 1 we actually covered the all the value types. In example 2 I have put in the 2, I'm bringing 2 the variables, which is a reference type, just to understand that how the data is going to be stored for this the small programs. And let me quickly open the memory allocation for this one. Now see here what is happening. We have the main stack frame again on line number 14, which is int num1 equal to 5. We got this thing got created. Okay, this one got created on line number 14. Then 15 and 16 we are creating employee 1 and employee 2. Now these are the reference types, and like I said earlier, in reference types the data actually gets stored on the heap. So when I say data, what does it mean? So your employee class objects, right? Your employee class, the data which is having ID, right? So the moment, I mean, this line number 15 is going to be executed, what CLR is going to do, it is going to find out this new keyword, then it will go here, it will try to figure it out all the local variables and entire memory which is needed for this one object, right? So it's going to compute what are the different the bytes it needed, and then it will allocate that space somewhere within the heap. Once again, I mean, as we know that heap is a disorganized the area, it is not a contiguous memory, it is a big like warehouse, right? You can put stuff at any place. So it will find the space somewhere in this large block of the heap, which you see here. It find a space here, it put it id it, and then this is that location, this address 0x200. So it allocated, it put it that, it got the reference, and then it give the reference back to emp1. So emp1 will have that their own address, keep in mind. Okay, so emp1, the actual emp1 reference, right, it's going to be stored on the stack and it will have their own address as well. But what data would be stored in that? Because reference doesn't store directly the data, but it is stored the reference of the another data. So in terms of the data wise, it's going to store the reference, which is the 0x200. That means what we are saying, that this is the address of this heap, and that address would be stored here. So that is a fundamental difference between a stack type and the stack and reference. Okay, now same thing apply to, you have another object, right? Another employee object, and then same thing. So it is, the basic, we are not doing any reassignment here in this program. It's a simple, the representation, just to understand that how, the values types and reference types differs, and where the memory gets allocated. Now let's quickly move to the next question. Now here what actually we are doing, that let me get the memory presentation as well. So we are creating a box one, we created one box one object. Again, it is a reference type, so data would be created on the heap. Then box 2 equal to box 1. What actually it means, that another variable we are declaring and assigning with the box 1. So the key thing is here, so box 2 equal to box 1. Now think about it, what is this box 1? Just like in previous examples we reviewed it, box 1 is a reference and actual data is stored on the heap, right? But we are assigning box 1 into box 2. So what exactly it is going to assign? It is actually going to assign the memory address, that reference, not the actual data, right? So let's quickly take a look here. So if you see here, we have memory address 0x300 of the heap. Box 1 is having 0x300. It means in the data we have the memory address of the heap. Now we are assigning box 2 equal to box 1. So what actually it means, that box 2 is going to have the 0x300. Obviously it will have their own address on the stack, but in terms of the data, now since we reassigned it, we reassigned box 2, assign box 2 into box 1. So box 2 is going to have the address of this thing as well. So what actually it means, that now you have got two objects, both are pointing to the heap. This is a fundamental difference between, the value type and reference type. Since this is a reference, actually we are copying the reference. In value type, you actually copy the actual data itself. Okay. Now, once box 1, box 2 both are pointing to heap, we have a simple assignment here, where we are changing the value box 1 dot value equal to 10. So now box 1 dot value equal to 10, since both, I mean, it doesn't matter, right? I mean, whether you do box 1 dot value or whether you do box 2 dot value, ultimately the point here is that both are pointing to the same. So it doesn't matter through which reference type you change the value, it is going to be reflected at both the places. Because think about it, it's like, you're the library book, single book, which two people have got the library card. So if you bring your home and you make some, the changes, whenever other person is going to check that book, he's going to see the same changes. So that's exactly the same thing is happening here. Now quickly let's move to the next example. um, I have tried to put some variation here so we all can the cover most of the scenarios. Now in this case, what actually we are referring, we are actually passing by values. So far what actually we did, that we saw that when you declare the the data type where it gets stored, when you declare the reference type and assign the value where it gets stored, when you assign a value type variable into another one, how the data gets stored, and same thing we did for the reference type. Now in this example, what actually we are going to do, that from one method you are actually passing a value type to the another method. And how does it works, how the data gets stored where? So you have got the mainframe, the stack. You have original equal to 10. Obviously, I mean, it is going to be stored within this the stack frame itself. and then it is calling another function and it is passing, this original value. What actually it means? So original is a data type. So if it is, a value type. So since it is a value type, when you are passing, what actually it means that it will pass a copy. Okay, remember. So when you assign a value type, it creates another copy. So you are actually passing original into this one. So what will happen? One more interesting thing, right? I mean, this is the first time we saw so far that we have two functions, one function calling to another function. So one thing to note that when this function would be executed, obviously this is going to be executed first. It is a static void main. So this will have your, the main stack frame. But since this is another function, so you are going to have another, the stack frame. So you are going to have the two stack frame. Okay, so let's take a look. You have one stack frame for, the main. Okay, so one stack frame is here, and then you also have another stack frame here. Okay, now both are going to store their own, the local variables within their stack frame. Okay, so this has got original, and then this gets passed into this stack frame. Now when this gets passed again, I mean, this is what actually it is going to pass. It is going to pass the actual data itself, because it is a value type, right? So it's not going to pass the address, it is going to pass the 10, right? So once this function would be called initially, this number variable will have 10. Okay, so that time both are going to have 10 and 10. Now on the line number 16 in here actually, so we are assigning number equal to 99. So what actually it means? It means that this thing which was initially 10, now its value changed to the 99. But keep that thing in mind that yes, I mean, this would be changing to 9. But what actually it is doing, it actually changing the value itself within on the stack itself. It is not going to reflect anything on the other stack, the from the variable. So this will have 99, this will have the 10. Okay, now let's move to the next example right away. Okay, so in previous example we saw the the calling a function and passing by the value type data. Now here in this example we are going to see the passing by the reference. Okay, so let me take a let me open this, the memory presentation as well, and we will go a little bit, the quick here. So score, my score equal to new score. Again, score data would be created here. This has got, the reference of that heap 0x400. Now from try changes score, that is another, the method, it will have their own thing. The interesting thing is that what we are passing here, we are passing my score. And what is my score? Think about it. What is my score? My score is having this reference data. So when you are passing, what exactly you are passing? You are passing 0x400. So on this, initially, this will get 0x400. Now, what actually it means? It means that you have got two two variables, both are pointing to, right? Both are pointing to the same. It's pointing to this, it's pointing to this. Both are pointing to same. So that means now it doesn't matter, I mean, which variable you are going to use it, right? Ultimately, the moment, I mean, if you're going to change it, is going to be reflect to other places, right? To each other. So once again, I mean, this is what the difference is, that by value type and by reference type. Okay, so now let's move to another variation which we have. Let's see what variation we have got. Oh, very interesting. So we are talking about the string here. Okay, so in C Sharp, string is having altogether a different, behavior. Um, So I just wanted to point it out here because sometimes, the interview, it is pretty classic question. People ask it, and then, even, the seasoned and programmers, I mean, get uh, uh, sometimes they are having difficulty to answer this one. So what is happening here? By definition, string is a reference type. Okay, so let's take a look what is happening here. So we have a stack, again the main stack frame. We have got variable s1 equal to hello initially, then we got variable s2 equal to s1. So what actually it means that, by we are having two variables, right? One and two. Okay, one is having hello and another one is having hello. Hello got, the initially hello got created here, and this is the hello address 0x400. So ideally s2 will have the 0x400, s1 will have the 0x400, so far by line. Now let me clean this one. Oh, sorry, let me clean this one. So far, right, this is the scenario. Okay, now what happened? S1 equal to what, right? So we are changing into, we are assigning into another value here. Now C sharp here does this thing very differently for a string. What actually it does, that it creates altogether a it allocates altogether a new space within the heap. Because remember, right, so far reference type, if you guys remember, right, whatever the example we have seen, what happens that when we change into the heap data, and so whatever the references and pointers are, right, it reflects it both places. Now very interesting thing is going to happen in this case, that we had 0x400 initially, both were having s2 and s1, but then the moment line 19 got executed, what it did, it didn't do anything with this. It ended up creating actually another space. Okay, another, it allocated the word actually into another, the another reason. It got a new location 0x400, and then it get back to s1. Okay, why it does that? The question is that why it does that, why it did that. Now what happened here, if you see here, so s2, see, the interesting thing is, the s2 is still having hello, but s1 is not now having word. Don't you think, I mean, it's a little bit, the contradictory, whatever the concepts we did so far. Ideally, since both are pointing to same reference and it is a heap, ideally, s1 and s2 both should have the word, but that is not how the string works, right? So C sharp does a little bit differently for the string. The reason being, in one line I can all tell you that it is because of the, you know immutable. String is considered as immutable. Now why in C sharp does like that, why we have implementation like this? This is a very interesting thing. I am going to leave this thing for you guys, that go ahead, research it, read it, and whatever you found it, drop on my comments, uh, or if you are not able to find, let me know. I can cover, as part of, some other episode. Okay, now moving to next, let's see what we have got. So example 6. Okay, now quickly I wanted to talk about the memory leak and, the stack overflow. The reason being that, obviously, since we are covering this, the topic, it is extremely important. Why even, going in that detail, and we are trying to understand that which gets stored where, right? The reason being that still the responsibility lies on us, right? When we are coding, is we have to be extra careful that what kind of variables we are, they're declaring, we are assigning, and we have to ensure that, though, I mean, C sharp does most of, the memory management through the garbage collector, pretty nicely, but still there is a chance that if we are not careful, right, we will end up having, the situations like memory leak, the stack overflow. This is a pretty simple example. If you see here, we have a leak, the class where there is a, the list has been created, and what it does, that it creates this list here, but within this, the function, uh, it creates, the 1 MB, the space. Now what will happen if you are going to run it? I mean, this is going to be, I mean, you call it stack frame, is going to be created, and then it keep allocating this one. Let me see if I have memory presentation. Yeah, so take a look what is going on here. So you got a stack, you got mainframe, right? And then, sorry, you got P, which is a, the reference type, and it is pointing to this address 0x600. And what it does, that it keep creating, the 1 MB space, 1 MB space, 1 MB space. And what is going to happen, it end up, it keep doing that. And if it's keep running like that, what will happen, that you will be out of the memory. Now quickly I wanted to touch base this one, the stack overflow. The same thing happen is if you are doing a recursive, if you are coding and you are putting, the recursive methods, you have to be extra careful, because this is one of the example. I mean, if you are not, let's say if we are not able to, by mistake or whatever, the situation is, if you're not able to find, the exit condition in your recursive codes, it will end up having, the stack overflow. The pretty simple example, if you see here, static void, let's start from here. Static void main, right? One local variable 99, then it is calling this function. What actually it means, that the moment this is going to be called, another, the stack frame is going to be allocated, which will have the local variable number. Okay, this is going to print it out, and then recursively you are calling it. Now in practical, what is going to happen, you will have main stack frame would be created. The moment the first time it is going to call this one, you will have another try change int stack frame is going to be created. Once this is going to execute, again this will call this one, another stack frame is going to be executed. So it's keep calling it, keep calling it, keep calling it. And what actually will happen, that you will have infinite number of, the stack frame is going to be allocated. And obviously, I mean, before infinite itself, I mean, like I said, that stack hardly, it gets 1 MB space, so it's not having a lot of space, and therefore, I mean, it will be, the out of memory. A pretty simple, the memory presentation, what exactly is going to happen. And if you see here, the 1 2 3 4 5 6, and then n number of times, and finally boom, you have stack overflow, the exception. uh Now, before we close it out, I quickly wanted to cover the reference type as well. If you see here, um, you have the main method, you have one local variable 100. We are calling a function here. The magic is here. The difference, I mean, magic or difference, whatever we can say. Here we are passing, the ref score. Think about it, that if you are not putting the ref here, then score is a value type. So what actually it will do, that it's like, this will have their own copy. But the moment you do the ref, what actually it means, that you are not passing the actual copy, rather than you are passing the address, right? The memory like address. So once you do the memory address here, again, I mean, you are not getting the copy, but you are actually passing the actual memory addresses. Now if you change the value here, what actually it means, that you are actually, the changing the actual data. So this will end up having the changes at both places. Both the places, I mean, that the original places. Okay, so I think we have covered, I mean, no, most of the scenarios, most of the possible, the permutation combination, which can be, which can be possible. Having said that, I mean, with this episode, I'm thinking that this was, the comprehensive breakdown of value types and reference types, and I'm hoping this has been insightful for you folks. Uh, it is a really nice concepts, which if you know, if you understand, I mean, it separates the, a basic C# programmer. Today we are going to cover the question number 4, which is, what is difference between boxing and unboxing in C#? If you have not visited the previous episodes, I would suggest please go ahead, take a look just the my question number 3, which I explain in detail. What is the difference between value type and reference type? That episode is going to help to understand some of the basic and nuances which we are going to cover as part of this episode. uh, let's start. So boxing and unboxing, these are two pretty important concept in C Sharp. The C Sharp type system contains the mainly value type and reference types. Boxing, on the other hand, it is a process that converts a value type variable into a reference type variable. Unboxing is the process is extraction of the original value type from an object and converts it back to the value type. So if you see, but it's pretty simple thing, and as the right, boxing, like you can guess it that you are trying to box something, right? So even in real terms, the way it works, that you are trying to you box a value type data and put it on the heap. That's what the boxing does, that you convert a value type data and box it and store on the heap, and then when you have to unbox it, you extract that value from the heap location and again put it back on the stack. So that's fundamental difference between boxing and unboxing. Now let's take a look the difference, which I just wanted to point it out in previous episode, which I covered it quickly. I want to touch base this once. So the value type is the place where the primitive data types gets stored, and value type is kind of a box which contains the actual data itself. Reference type is the kind of data type which doesn't store the actual data, but it has got a reference which points to the actual data on the heap. So value type data goes on the stack, reference type data goes on the heap. Now we will directly move into the boxing and unboxing code. I just wanted to reference what is value type, reference type, because this is fundamentally, this is how we are going to understand it. But let's take a look the boxing and unboxing, the sample here. So it is a simple code. The main method, it is one of the integer n equal to 100. Obviously it is a value type, so what actually it means that it is going to be stored on the stack, and then we are doing the boxing. Now see what actually it is trying to do. Object box equal to n. So what it does, that it is trying to convert a value type variable to a reference type. Boxing is an implicit conversion process where a value type is wrapped inside an object instance and stored on the heap. So when they are fields within a reference type, they are part of the heap allocated memory. Now we will actually take a look a little bit detailed. So let's try to understand it. And on the last line, if you see, the opposite is happening. Now let's try to do a little bit deep dive of the boxing. What happens when we do the boxing? So since in the boxing we are trying to convert a stack data which is stored on the stack to the reference type. So let's see what is happening here. Int I equal to 100, and then in the second line you have object O equal to I. So int I equal to 100 means this data is on the stack. Now the moment you do object O equal to I, what it does, that CLR actually goes and allocate the memory on the heap, put that that values the 100 there, return a reference type, a pointer, and object O, obviously it is going to be stored on the stack. Please I think there is a misspell here, so ignore that. Simply on the bottom, the yellow thing, simply it is trying to say that it is a object O. So that's what happens when we do the boxing. uh, it's a simple process. Now let's take a look what happens when we do the unboxing. So in the unboxing, it is a process of explicitly converting a box object back into its original value type. Now keep in mind, I mean, the interesting thing, if you see that int j equal to, and then there is an explicit cost, the casting, which says that int, and you have the o here, right? So in unboxing, what actually we do, we first create a value type integer I to unbox the value from the object. So unboxing require explicit casting. The object must contain a valid box value of the correct type, otherwise it's going to give the invalid cast exception. Thus the reference type variable residing in the heap memory is copied to the stack as shown in this figure. Okay, so now let's understand one more thing. I mean, there are some few important consideration uh, which is very important to understand it. So performance override, right? So as you saw that whenever we are doing a boxing, what is happening, a new object is getting created on the heap. Okay, and which involve, like, CLI has to go ahead, identify what is the memory needed. It computes the bytes, how many, how much space need to be allocated, and then it reserve that memory, return the address back to on the the reference, the pointer which is stored on the stack. So that means CLI has to do all this processing. So that is what happens. I mean, whenever in our program, especially in the loop, if we are doing boxing and unboxing, it slow down your application. So we need to be very careful and try to avoid not to do boxing and unboxing. Another thing is that, which I already mentioned, that you have to be very careful when you are doing the unboxing, because when you do the unboxing, you see under type safety and exception, you have to be very careful that you should try to unbox to the actual data type which initially used when boxing happened. For example, in this, the three lines of code, two lines of code, if you see object ob is equal to 10, and assumption is that initially that 10 was the integer value. So here object ob is equal to 10. I mean, in the heap you have what, you have actually the integer, which is a which has to be on the stack, right? Now in the next second line, if you see, that integer is, we are trying to convert into the double, right? So if you, that integer cast which we have, if you see in the second line, if that integer cast you are not going to put it there, then it is going to give the invalid cast exception. The reason being that on the heap the data is on integer, right? Now once you have that int, then you can convert into double. So the second syntax, second line of the code is going to work. But what actually I am pointing out, that the other two casting has been written on the code, double and int, and that int thing is necessary to have that, otherwise it's going to give error. Another thing is that, like I said, I mean, we should try to avoid the boxing and unboxing, especially before the generics got introduced. I mean, we had only the array list, and array list is kind of the data type where it accepts the objects, means you can put any kind of the data, you can put integer, you can put a string. So whenever you put anything, obviously, I mean, internally behind the scene it does the boxing. But now with the introduction of the generics, all that the boxing operations can be avoided. So it's always advisable to use the generics as much as possible, so you can performance wise your application will not get hit. Today we are diving deep into a concept that's absolutely the fundamental to C Sharp as well as object oriented programming. It's inheritance. So we are going to talk about what exactly is inheritance, and as a agenda we are going to discuss some in the basic definition, how why we use the inheritance, some of the the core concepts. We are also going to touch base some of the advanced topics, nuances, as well as the best practice. So let's start right away. What exactly is inheritance? So inheritance is a relationship. What exactly it means? So inheritance allows a new class, which is called as a derived class, to acquire properties, methods, and events from another existing class, which is called a base class. So if you take a look, this diagram, there are two terms, derived and base. So derived is a class which you are trying to create it, and you are creating this new class by utilizing from the another existing class, which is a base class. And the idea is that this derived class is going to derive the lot of the things which already exist. So what actually it means, that well, as an example, a dog is an animal, a car is a vehicle, a a saving account, a checking account is actually a bank account. So if you see, right, uh, is a relationship. The dog is a animal, a car is a vehicle, right? And same thing like bank account, right? Checking a saving account, or a fixed deposit account is actually a financial bank account. So consider that you are developing a software in enterprise, the organization, and you are working on a banking system. And then these are the separate objects. You have saving account is one object, you have fixed deposit is one object, and then it's a sophisticated system, right? So this is how you can take advantage of inheritance. You can create a bank, the account, which will act as a base class, and you can put some of the data members within that base class, which is common to all other accounts class which you are going to create it. And then you can take advantage of the inheritance. So we are actually going to take a look the code as well, uh, once after a few slides, and we will try to the understand it. So let's dive in right away. Okay, so I have one pretty basic inheritance example here, the way I was trying to explain you. So we have account class, and we have two data members actually, base class data, account number, balance, and then we have one function. Okay, in object oriented words, a class is actually a skeleton or a blueprint which contains the data as well as behavior, right? In technical terms, data means the variables which we declare it, right? The data members which we declare it, like account number, balance, and behavior is the functionality, the function which we created, the events which we created. Okay, so quickly, account is having account number, balance, one function. Okay, now then this is a saving account which is inherited from account. So in C Sharp, the syntax wise, you put a colon and then you put the base class name, and then these are some of the data members and methods of this the derived class. We have interest rate, withdrawal limit per month, this one, and a function. Okay, now coming a pretty, the simple example how you can use it. So we are creating object of saving account, which is a derived class. Now see, the interesting thing is that account number and balance both are actually defined within, the base class, but you are able to access it within the derived class. Why? The reason being that derived class is actually inherited from the base class, and what actually it means, then all the, the members, all the members which is defined in account, derived class has access to it. It gets inherited. Now I want to put a disclaimer when I say that all the members can be inherited. Again, it depends, right? So normally public and protected are the one which derived class, get access. If it is private members, derived class will not able to access it. So see, I mean, how, it is able to assign it, and then it's able to, the call this function, the deposit, which is actually defined within the base class. So this is how inheritance, the works. Now why you do that, like I said, right? You can have, if you have some common behavior, right? So you can create those, the objects in a base class, and you can put all those, the functionality, all those behavior, as well as the data in the base class, and then you can have, the derived class. That is how you take advantage of inheritance. So now since we covered pretty basic example, let's take a look one quick, another terminology, which is called method overriding. And why I want to talk about it, because it's pretty, the closely, the related. Uh, a key aspect of inheritance is the ability for a derived class to provide its own specialized implementation. So if you take a look this diagram, I mean, left hand side it is one box, and then right hand side it says override. Now I have put those three, the pillars to represent, a financial institution or banks. The reason being that since we are covering, our examples are based on, the bank accounts, what actually I'm trying to indicate here, that override let you let derived class to implement, extend its own functionality. That is what override does. So what actually it means, that you have some behavior within the base class, but in derived class, with the help of the override, you can extend that functionality. Now let's take a look the code, how it works. So account, again, the base class, we have got account number and balance, and then we have this deposit function. Now within deposit function, the default behavior within a base class is that, I mean, it does very simple thing, that it checks that, the amount should not be less than 0, and then it allows you to do the deposit. And here if you see balance plus equal to amount, it means whatever the amount you keep, depositing, it's going to add into your existing balance. Now let's take a look here. Then you have the same function with the deposit, okay, and it's having its own now this time it has got a custom implementation. So what actually you are doing, I mean, we are actually extending that functionality. So that is what override does. Now what is the syntax, how you do that? So in base you put a virtual keyword, okay, and in derived class you put override. So in that case, what actually you do, that derived class actually override the behavior which you define in the base class. So here if you create a object of, the derived class, and if you call it, so see here how it's being, the used. So in main, we are creating one object of the base class, another object of the, the derived class. And again, I mean, since it is a derived class, you will have access to data members, public data members, and protected data members, which is defined in the base class, which is account number, and we are defining a interest rate. Now here if you see here, so here we are calling the deposit function, by using the the base class object, right? So deposit we did. Now here saving the deposit. So what actually it means that you will be able to utilize, right, the both features. So here the saving dot deposit, that means that derive class is calling its own implementation. um, so that is how you can take advantage of override, the method overriding. Mainly it is called the method overriding. Now let's talk about another, the very important concept, abstract as well as the sealed. So it, what exactly is the abstract class? And take a look this diagram, right? I mean, this pic, uh, one right hand side, it is a sealed, which is represented as it's a lock, it's the closed, you will not able to open it. In abstract, I mean, there is a small space left. What actually it means that there is a there are some space where you can the extend it. So how we can define what exactly is abstract and what is sealed, and how it is related with the inheritance. So abstract is a class that cannot be instantiated directly. In other words, you cannot create object of abstract class itself. So then, I mean, how you are going to use it? The question is that how you are going to use it. So the idea behind abstract class is that it always act as a base. The words you have to, it is meant to be inherited by other classes. uh, that is what the abstract class is. Another key feature of abstract class is that it can have two kind of implementation. It can have abstract methods, and it can also have non-abstract methods. What are the abstract methods? Abstract methods are those methods which are just like the abstract class. It will just have the body of the function. In other words, you will not have the implementation inside it. That is called the abstract methods. And then you can have the normal non-abstract methods, where you can have implementation as well. In just right away, I mean, we will take a look the code as well, that how it works. On the another hand, the sealed is that this is a class which you define, so nobody can inherit it. In other words, a class that cannot be inherited further. And the idea is that it is used to prevent modification or extension of a class. In other words, you cannot modify it. Okay. And why you will use the sealed class? Again, I mean, all these are uh, uh, fulfill different use cases. So you can use abstracted some other places, you can use sealed on another places. But the idea behind the sealed class is that you normally often use for security and optimization, or when a class is final by design. I mean, it is a final and you don't want any changes in that class. So let's right away jump in and let's see the code as well. Okay, so again, the same account class I have turned into abstract class. Same data members, we have got deposit. Now keep in mind, I mean, these are the main key things, that this is an abstract class, and like I was explaining earlier, that it can have abstract methods as well as non-abstract methods. So this is abstract methods, and if you take a look, that it has got just a body of the method. There is no implementation, right? You don't have logic inside the method itself. I mean, you just declare it and you finish with the semicolon. There is no open parenthesis, and there is no code inside that. So in other words, you just they declare it. And then you have got one function which you have got the implementation. Now saving account, derive class inherited from account, and you have got deposit here. Now keep in mind, now interesting thing is that here you have got abstract, and here you have got override. So what actually it means, that abstract methods has to be overridden, right? So the derive class has to do the implementation of a abstract class. So this saving account, derive derived class and implementation of this method is here. Now another class, and this is the example of a sealed class. So you have a sealed class fixed deposit account, which is again inherited from the account, and then you have got the deposit. The reason being that since you are inheriting a abstract class, so you have to be do the implementation of the abstract methods. So this is there. Now the key, take a look this word, actually the sealed word, actually it means that this class cannot be inherited further. You cannot have derived class of this. Okay, now quickly again, I mean pretty simple. We have static void main, and we are creating object, and then we are calling these functions. So this is a demonstration. This is a simple example, pretty simple example, how the create abstract class, how we define abstract class, and how you use it. Now moving to the another interesting topic, that since we are talking about the inheritance, is there any alternative of the inheritance, and what should be the right place to use it? So while inheritance is very powerful, but inheritance should be used accordingly, just like any other concepts, right? I mean there is nothing in programming where one thing fits it all in all situation. That is not the case. So the when exactly you should be using the inheritance, and this is very important thing. Sometimes the interview people ask it, that what is inheritance and what is the composition. Is there any use case where you should not be using the inheritance? So the golden rule is that is a relationship. That is the golden rule. Is a relation means what, right? If you have a situation where there are the objects within the object-oriented programming where they are sharing the common behavior, yeah, right? Just like dog is an animal, or car is a vehicle, right? And the account scenario which I said that, right? Or a manager is an employee, right? Or a square is a shape, right? So there could be the ton of example. So wherever is a relationship that is the best fitted for the inheritance, we should do that. That is where you can take advantage of it. But some places, right, it's not is a relationship, rather than it's a has a relationship. For example, car has engine, right? So there is no the inheritance kind of things between these two objects, right? So that is where you should go and you should use the composition. Now quickly, I think we talked about all the things related to the inheritance. So quick, before we wrap it up, that what is inheritance? So it is a relationship. Why we use inheritance? The benefit is that it's a reusability, right? I mean if you have ton of objects, and all if all them share common behavior, right? So with the help of the inheritance, you can do the code reuse. It improves, it follows the drive principle, right? Virtual override. So you can have virtual, and then you can have you can override it. And inheritance is the first ladder to implement the polymorphism. So my next question is based on the polymorphism. I'm going to discuss in pretty detail, and we will take a look the codes, and we will do the live samples, etc., right? But it is the first, it introduces the polymorphism. It with the inheritance you achieve the polymorphism. Abstract, again, I mean blueprint, I mean it just creates a blueprint. You cannot have the instance object of the abstract classes, and then it forces the implementation in the child class or derived class. What is the sealed is something which is a final, the final design. You don't want any changes in that class, and that is where you should be using the sealed constructor. So whenever the inheritance, the first constructor which gets executed, it is the base constructor. So base constructor gets run and executed first, and then derive. What actually the access modifier modifier gets, the access within the derived class. So what actually you inherit public, you inherit protected, you do not inherit, the private. And once again, inheritance, you should be using wherever it is a relationship rather than has a relationship. If it is a has a relationship, you should go for the composition. Today we are going to talk about one of the very important topic, polymorphism. So what exactly is polymorphism? The word itself gives us a huge clue. Polymorphism, it is made from two words. Poly means many and morph means form. So in C#, polymorphism literally means many forms. In other words, in terms of the object-oriented programming, it means the ability of an object to take on many forms, or more accurately, the ability to treat objects of different classes as objects of a common type. Let's try to understand the concept of polymorphism with this image. The person on the right hand side is calling a method animal.speak. So this represents a generic or general command like asking any animal to speak. On the left hand side, there are different animal objects. So dog responds with woof woof, the cat responds with meow meow, and rooster responds with cocky doddle doo. Even though the same method speak is called on each animal, the output is different on the actual object. So once again, polymorphism, the way we defined it, one method, many forms, the ability of an object to take on many forms. That is what the polymorphism is. So right away we will dive into the code and we will try to understand with the help of the looking the code as well. So let me quickly show a basic the example of the polymorphism. So we will start with pretty the simple, the same code, the image which we saw. We have an animal class which is having a generic implementation. Then we have three these the derived classes, the same thing which we saw in the image. We have a dog, cat and rooster, and if you take a look, all these three objects, it's having its own implementation. Now when we are creating a collection of objects which is having dog, cat and rooster and calling the same speak method, all these objects are behaving differently. That's exactly what the polymorphism is. Okay, so let's try to understand what are the different types of polymorphism, how you achieve it. So mainly there are the two types of the polymorphism: compile time polymorphism and runtime polymorphism. Compile time polymorphism is also known as static polymorphism. The reason being that at the time of the compilation itself, compiler knows that which method to call, right? How to resolve it. In terms of the runtime polymorphism, it is also called dynamic because at compile time, the method, it will not able to resolve that which method to call, right? It normally gets done at the time of the runtime. So that is why it's called compile versus the runtime. Now again, let's take a look the real the code to understand. So let's start with compile time polymorphism. We have a simple calculator class and then we have three methods with the same name, add. In the first one we have two arguments, return type integer. In second method, instead of two arguments, the parameters, we have the three. And then the third one, we have two parameter, but the data type is different. Now let's see how we are calling it. So we created an object here and then we are calling the same add method, but the different values. So in this add, we are passing 5 and 10. In second one, we are passing the three parameters, and then here we are passing the double. So that is so if you take a look, the interesting thing is, right, all the, in all the three methods call, right, we are calling the same method, because it's add, right? But depending on the parameters, compiler already knows that which method to call. So for example, in this case 5 and 10, these are the two, the two whole numbers 5 and 10. It will be able to resolve and it will be able to call this one. In this case 3 parameters, it will be able to resolve and it will be able to call this one, and same applies for this one. It will be able to identify that, hey, the parameter is double, so it has to call this one. So this is the polymorphism through the compile time, through the method overloading. It is called method overloading, where you define the same method with the same name and then your signature is different. So it is called the compile time polymorphism or static polymorphism, which you achieve through the method overloading. Now let's take a look the more powerful, actually, the polymorphism forms, which you achieve through the runtime polymorphism, and it is also called, the method overriding as well, because you achieve through the method overriding. So just to give a little bit, the definition or how you achieve is, method overriding occurs when a derived class provides its own implementation of a method that is already defined in its base class. So for this to work, the base class method must be marked with, the virtual keyword, and in derived class it must be marked with the override keywords. So whenever anybody talks about method overriding, keep these two keywords always close to your mind, that it is virtual and override. With the help of these two keywords, method overriding gets achieved. Now let's take a look the example right away. So we have one bank account which is going to work as a base class or parent class, and it is having, the two one two actually the three methods. So it has got deposit method, which is having its own generic implementation. Then we have the withdraw method, and then we have the display balance. So pretty simple, the class which is responsible to, handle the deposit, withdraw, and the showing the balance. Then we have one, the derived class, saving account, and then it has got its deposit method, its own. So what actually it means, that it has got its own implementation. The same applies for the withdraw as well. It has got its own implementation, and the logic own implementation means that it has got a little bit different implementation than the generic one. Okay, so I'm not going to in detail that, in detail about the logic what is different, but mainly, I mean, think about it, that it is a saving account, so you got bonus on this. When you are doing the withdraw, there are some, the check and balances that, you should have sufficient fund to get, to perform the withdrawal. And then apply interest. I mean, you can also apply the interest. Now checking account, which is another derived class, and it has got, its own implementation of the withdraw. It's not having the other, the two methods deposit. It's not having deposit implementation for the checking account. Now the main thing, let's try to understand here, which is interesting, right? So we created the, one object of the base class, then we created object of saving and checking, and see that how the polymorphic behavior is being achieved here. So here we call the generic account, right? So generic account deposit gets called. Obviously what actually it is going to do, it is going to call the base class deposit method. Then my savings dot deposit, so my saving, which is a derived class, and it is actually overriding the deposit method. If we take a look, in base class we have a virtual and deposit, and then in saving account as well we have override. So what actually it means, that it is overriding the deposit method. So whenever you are going to call the saving account object and deposit method, this implementation is going to be called. So this is how polymorphic behavior is getting applied here. So saving account deposit is going to be called here. The same thing, the saving account withdraw, okay, and checking here. Excuse me. Now, uh, let's see this example, right, how it is being invoked. So we created a list, the collection of bank accounts, and then we added these, the five objects. When I say five objects, what I mean that we added one generic account, one saving account, one checking account, another saving accounts, and another checking account. So there are the total five objects within this list collection, and then we are calling these methods within the loop. So see, quite interesting, right? So when display balance is being called, no derived class is having its own implementation. So what actually it means that it is going to call the base class or display balance, but here the account or deposit, right, deposit is having different implementation. Saving account is having the implementation of deposit, but checking account is not having deposit implementation. So what actually it means that when saving account is going to call this one, it is going to call the saving account deposit implementation, that method, but for checking it's going to use the base one. In other words, I mean, it is a generic implementation for any other classes which is not having the deposit methods tagged with the override, and same applies for the withdraw. So in our example, both are having withdraw, whether it's a checking account or whether it's a saving account, and therefore it's going to call its own implementation. So see how powerful the polymorphism is, that you are able to change the behavior at runtime. Okay, so now let's move on. How you can achieve polymorphism. There are different ways to do that, right? I mean, mainly, I mean, we touch base method overloading, and we touch base, the method overriding. But apart from that, right, I mean, there are the different other ways as well you can achieve the polymorphism. So operator overloading is another one, where again it is a compile time and you can achieve polymorphism in web API, as well as uh, enterprise level application. Normally you don't use operator overloading a lot, but in case if you're going to work like the aesthetics classes, some maths like vertex and all those things, right, so that is where the operator overloading people use it. Abstract class, again, I mean, it can have abstract as well as non-abstract methods, and then wherever you have those the abstract methods, I mean, you can use the override, and then you can achieve the polymorphism. That is, again, I mean, since it is the override, I mean, it is a runtime interface implementation. That is another way you can achieve polymorphism. So in interface implementation, the way you do that, you define the interface, you define the contract there, and then all the derived classes which implement those interfaces, they have their own implementation. So that is another way polymorphism gets achieved. And then delegates, lambdas, as well as the generics. I mean, those are some the different ways you implement the polymorphism. Now let's touch base quickly some the tips in case, I mean, you are in interview and interviewer is talking about the polymorphism. So one thing is that define polymorphism clearly. And when I say define polymorphism clearly, what actually it means that mention the both types, the compile time, runtime, mention overloading as well as the overriding, explain that what are the main keywords: virtual, override, abstract, right? I mean, these are the mainly three keywords. You use it in order to implement the polymorphism. Discuss the benefits. I mean, what is the whole idea behind the polymorphism, why people use it? The simple answer is that reusability as well as the flexibility, right? Also mention the interfaces as well, that you can use the polymorphism through interfaces as well. And it is pretty the typical and interesting question many times interview ask, that can you achieve polymorphism without inheritance? Yes, interface is the way. That is how you can achieve the polymorphism. So, all right, that was all about the polymorphism today. We covered, the definition of polymorphism. We talked about importance. We talked about, the compile time polymorphism, method overloading, runtime polymorphism with method overriding. We also covered, the virtual override keywords. We also touch base that what are the different ways you can implement polymorphism. And today we are going to talk about question number 7, where we will talk about difference between method overloading versus method overriding. Now, before I jump into the details, I just wanted to let you know, folks, that if you have not visited any of my previous episodes, I would highly recommend you start from the question number 1. In previous episode as well, I touch base the polymorphism, which is pretty related with this topic. So if you have not done it, please go through, take a look. Feel free to add some comments or questions if you have any. Now let's dive in right away. So once again, the topic today is that we are going to discuss about the difference between method overloading versus method overriding. And it's a very important question as well as important topic. Interviewer always ask, if you are going for a C-sharp, the interview. So what I have done, instead of starting with the theoretical, right, to explain what is the difference, let's start with, the real sample, the examples, how method overloading and overriding works. So let's start with overloading. So I have a sample class document editor, and what it does, that the functionality is, think about it, that you are saving a document, okay, and you have different variations. So you have 3 save methods, all are having, the different variation. So the first one is having no argument at all, and think about is that it provides a default save. The second one, it takes one argument, new file name, and the idea is that it is going to let you to save the file with a new name. And the third one, which is having a file name as an argument as well as a boolean variable to upload the same file on the cloud. So 3 different variation, method name is same. The key thing is that you have exactly the same method name, but your arguments, your signature, right, is different. That is how you do the method overloading. And why you do that? It gives you the flexibility. It allows you to use the same functionality in different ways. Just like here, that depending on your need, right, you can use any one of these, the 3 functions. Now let's jump into another sample and take a look right away. We have another sample class, store search. So think about it, that you have got a store and then you have a search functionality. You have to build a search functionality, but then your need is having covering the different use cases. In first one, you want to give a capability to search by keyword. In second one, you want to give a search but within like category itself, right? And then the third one, where you want to search by item ID. And then the last one, you can have, let's say that you want to give a keyword, but at the same time you also want to give a filter that it's between this price to this price. So again, same concept here. You have same, the method name, but your arguments, your parameters are different. Okay, so that is how you do the method overloading. Okay, now let's jump into method overriding. So in method overriding, we have a base class. The way you do that, you will have a base class, and then you will have one method which is marked with a virtual keyword, and then you will define the derived class, and then the same method which is marked with the virtual, you will put a override keyword, And then what actually you will do, you will put your own implementation. So this is how you do the overriding. You are actually overriding this method, overriding the method of the base class. Okay, in other words, you are providing a custom implementation. So in this case, animal is base class, dog is derived class, then you have another derived class which is a cat, and then you have another derived class rooster, and all these derived class are having their own implementation. So this is how you do the method overriding. This is how you do the override. Okay, so what is the conclusion? I mean, if somebody asks what is the overloading, what is the overriding, right? So let's try to define it. Now we have gone through the samples, right, and examples, and we understand how to define what, but how you will define it. So in simple terms, overloading is the ability to define multiple methods with the same name but with different signatures within the same class. A method signature consists of its name and types of its parameters. On other words, right, it gives a flexibility. It gives a flexibility and gives a different variation. Now, what exactly is the overriding? Overriding occurs when a derived class changes or customizes the behavior of a method inherited from a base class. That is how you do the overriding. Now let's take a look, the quickly side by side comparison before we wrap up this episode. Method overloading, you define multiple methods and your signature are different. In overriding, you actually define a new implementation. You don't define a different method. You have the same method, but you do a different implementation. You write a different logic, different code within your base class. Relationship, you do not need any relationship in order to do the method overloading, but in overriding, relationship has to be there, inheritance has to be there. You need one base class and you need one, the derived class. Okay, method signature, you will need to have the different signature, and signature means that you can have the different the arguments, the return type and all that things. Method overriding, you need virtual and override keyword. Okay, so keywords modifier, no special keywords you need. I mean, you don't need any keyword to identify that this is method overloading. All you need, the different the different variation of the same method names. But in overriding, I mean, you will be able to identify, and the keywords is that in base class you will have virtual, and in derived class you will have the override. Now binding resolution, what actually it means that how compiler resolve to which function it's going to call. So the overloading, method overloading is compile time polymorphism or static binding. Compiler already know that which method to call based on the arguments. Method overriding is actually the runtime polymorphism. Only at a runtime it determines that which behavior, which function to call, and that's it. That's wraps up the differences between method overloading and method overriding. Hi everyone. If you have ever got confused what exactly is abstract class and what is the difference between abstract class and interface and which one you should be using in what condition, you are in the right place. So let's start to understand this concept by a simple visual which is being shown here right now. Let's start with this. On the left hand side, you have got a partially built house. This represents an abstract class. It is a structure that's in progress. It comes with the shared wall, foundation, and maybe even some plumbing. But the key thing is that it's not finished. It's not complete. Abstract class behave the similar way. So you inherit it, you define a derived class, okay, and you inherit it and then complete the rest of the functionality. On the right hand side, we have got a signed contract. That is the interface. If you see the document, so it indicates that a contract. This is the interface. It tells you what is required but gives you nothing pre-built. You are saying, I agree to provide these features. So here is the quick takeaway, right? In order to understand what is abstract class and what is interface. Abstract class is a relationship. It defines identity with the logic. Interface is can do. That means it defines capability with no logic. Let's jump into the code to understand this a little bit better. Let's say we have some payment types which require fraud checks like credit cards, but not all payment types need the fraud check. And this is the perfect use case of an interface. So look here, I mean, there is an interface here and with the name of iFraud check, and it is having one method defined run fraud check. So interface iFraud check defines a capability. So this defines a capability, not an identity. It's saying if your class can do fraud checking, go ahead, implement this. That's what interfaces are best for, sharing the intent, not behavior. Now we define a base class payment method. All payment types, whether it's a PayPal, a crypto, a credit card, right, have an amount and can print a receipt. So it is a shared logic, right? So let's try to understand this. This is an abstract class. It's having an amount field and it is having a method defined print receipt. And then we have abstract method process payment. So all the payments, right, whether it's a credit card payment, PayPal payment, right, they share the shared behavior, which is the print receipt. In terms of the process payment, this is an abstract method. What actually it means that it is not complete. So derived class is having responsibility to complete it. And derived class is having a flexibility to customize the behavior of this. That is whole the fundamental concept behind the abstract class. In other words, it tells that share the code, which is this one, and force required behavior. So this is going to force the required behavior. Derived class has to implement it, and then it also enable the inheritance, because you cannot create the object of abstract class directly. You have to inherit it. That's the whole idea behind the abstract classes. Now see, so these two are the concrete classes, the credit card payment and PayPal payment. Credit card payment inherits the payment method as well as the iFraud check. It shares the logic for printing receipts uh, by using this one, right? Because since it is a child class of this payment method, right? So since it's inheriting, so this method is shared, right? It can use it. So it shares the logic of printing receipts and customize it how it is going to process the payment, and adds a fraud check as well. So see, I mean, it is a classic example here where you can use the abstract class as well as the interface together. So you have now two real word class with completely different, the combination of inheritance and capability. So here credit card payment implementation you see here. In PayPal payment, which is not require the fraud check, right? So it is inheriting the payment method. What actually it means that it is going to share the print receipt, but it also at the same time it also implement the process payment as well, but in its own way, and it doesn't need the fraud check. Now how we are going to use it? So we are creating here, we store a credit card payment in a payment method variable here, and then we are printing the receipt, which is a shared logic, and then we are checking the fraud check.
If we can do that, then we are going to run it. So this flexibility is the whole point of using abstract class plus interfaces together. So let's wrap it up, right? So what actually it means. So coming back again on this, the visual interface is a relationship. It shares the logic. It allows a single inheritance, can include implemented methods, right? Which derived class can share it, can use it. On the other hand, a interface is a can-do relationship. It defines the contract, and using the interface, you can have multiple inheritance and no logic. Okay. Now, one thing I want to add here, that with C Sharp 8.0 introduction, uh, Microsoft came up with this concept that when you are defining an interface, you can have a default implementation in the interface as well. But I can tell you that in real life, right, even today, most of the real enterprise applications, people still define and consider interface is as a contract only. So, if this visual and plus code walkthrough help you clarify the things, that what is abstract class, what is the interface, and in which case you should be using one to the another. Hope it is the helpful for you. Please do let me know in the comments if you have ever mixed up these in a real life project. You are not. Today we are covering the topic namespace. We are trying to understand what is namespace in C Sharp. So in programming world, especially when your projects grow and your projects become thousands and thousand lines of code, it is very hard to manage the code. And then you need a proper organizational system. Let's try to understand with a simple example. Uh, let's say you have a kids in your house and you have bunch of toys. Yeah, and how do you manage those toys? You keep different kind of boxes, you bring different kind of boxes, a container system, and then you put, depending on the category of the toys, you start putting those boxes. If you have Legos, it goes into the Lego box. If you have cars with the battery system with remotes, right? You put in one of the boxes. Similarly, if you have magic tiles, you put in another boxes. So same thing in real world, in programming also happens the same thing. Namespace works like a boxes, right? Where you have the related codes which you put in one of the namespace. Let's say you are working on a mapper classes, so all the codes related with the mapper classes you would like to put in the namespace, which starts with mapper or something. You have put it, right? Similarly, you have data access logic, so you can put in namespace which start with the data access, with the name of data access, right? So that's the whole idea behind the namespace, is that it is a logical container where you can put all your codes inside that namespace. Let's try to understand with the proper example, right? And what the problem namespace solves. So let's say that you are working on a employee module where there is a person object which is having employee ID and employee name, and class name is person. And then you have another module, let's say it is a CRM module where you are representing a person object as well. Here the only difference is that person is not the employees, rather than person is a customer, and you have properties like customer ID and email, right? But again, this is also a person, right? So if I try to build this system, it's going to give a error message that hey, your namespace already contains a definition of person. Why? The reason being that there is a person object already defined here, and then we are defining another person. Actually it's a vice versa, right? So it's giving error for the other class. So there is a person object here, the customer person object is already defined here, so we cannot define another person object, right? And that's where the namespace comes into the rescue. Let's try to solve this one. How we are going to fix it? So what we can do, we can define the namespace, and this one is the employee one. So we can do something like my company dot HR system. We can do something like that. And we can have here this one. Now this one is a CRM module, right? So we can do something like namespace my company dot CRM system. Let's come here, and that's it. It's simple solution, right? So all we did that we wrapped the class inside two different namespaces where it makes sense. So we put it the customer person object within the CRM system, and we put it the employee person object within the chart system, and that's it. I mean, it solved the problem. So that is how namespace you use it, you organize your code. I mean, this is extreme simple example, right? But once you will work on the real project where you have thousands and thousand lines of code, and you will have like a lot of codes to perform one thing, right? So you can organize the namespace. What other advantage, what is the other benefits of the namespace? So one thing is that you logically group your code within the namespace. It allows it resolve the naming conflict issue. It also improves your readability. When I say readability, what actually it means that once you read your code, right, and the moment you see the namespace, you will be able to guess it, that what this code is all about. Let's say if it is UI related code, right? So you can have something like UI, you have data related code, you have data access logic code, you have business logic, or the anything. So that's how, right? It improves the readability. It also improves the reusability. When I say reusability, namespace, uh, if somebody using your library, and let's say you have code and you have defined some of the codes in your library, if somebody is using it based on the namespace, the person would be able to understand that, I mean, there is some code already exists. So uh, that is what namespace helps in terms of the best practices. You should be using a proper naming convention when you define the namespace. The best way is that use the Pascal case, for example, the way this is being here, rather than don't go like a small case here, something like that. Don't go there. uh, the Pascal case is best suited for the name cases. You can also follow the hierarchical structure. What actually it means that you can design your namespace to reflect your project's logical structure. Start with your, the company or project name, and then drill down into the modules or layers. For example, your company dot your project dot business logic, or your company dot your project dot the data. So that's how you can do that. And that's it. I mean, we saw a practical look at namespace in CSharp. This might seem like a small detail, but mastering them is crucial for the writing clean, maintainable, and scalable C# application. And that's it. Hey everyone, this is Jay, and welcome back to Step by Step Coding. In C Sharp, whenever you code, you use these words: public, private, protected, internal, protected, internal. These are called access modifier. These control who can see and use your code. So today in this episode, we are going to break down all 5 access modifier with a simple hands-on coding demo. Let's jump into the code right away. So to start with, what I have done, I have created a solution, okay, and I have 2 projects here. One is having the main project, which is going to have public static void main, where we are going to run our code, and then I have created one library project. So this is where we are going to add, our access modifiers one by one, and we will demonstrate it that how these access modifier impacts, and what is the difference between these 5. What are the access level? What is the difference between access level of all these? So we will start with the public. Let's start with the public. So what I'm going to do, I'm going to use this. Let's say I have a method call ring doorbell in the house. Okay, this is a public. Now this comment says that anyone can ring the doorbell. What does it mean? This is a public. Okay, so simply what we will go into program here, and we will create this object house, new house, and then let's try to access it. So all good. I mean, compiler is not giving any warning or anything like that. If I click on go to implementation here, it will be, I mean, editor will be able to navigate here. So it indicates that it is accessible. Let's try to run this one. And here we go. Ding dong, someone is at the door. So it is a public access modifier. What actually it means that this can be accessible anywhere. And the proof is that if you see here, I mean, this is defined within the house class. We went outside of assembly. So we went another assembly, which is main app. And within that, we are inside the program class and we are able to access it. So this is what the public is. Now, it, with the contrast, of the public, private is completely opposite. Private is that you will only able to use within the class itself. So let's say that you have a Wi-Fi password within your house as an example. Okay, so I am going to put this Wi-Fi password. Let's say this is something like super secret password 123. And what I'm going to do, let's come outside of the assembly and let's say that someone is trying to steal that, okay, and try to change it. So I am changing it, okay. Now if you see right away, we see this thing. So compiler is giving a warning. And if you see here, not warning, it is a error message. It's kind of error message. And if you see here, house.wi-fi password is inaccessible due to its protection level. So that is what the private is. It is only accessible within the class, not outside of that class. Here we tried outside of the class. Let's try one time inside the class. Okay. So I will comment this out here, and let's put here not accessible. I will put it here, and let's try to access here. If I will access here now, new password, see, it is accessible within class. Can access private member. Okay, so this is what the private modifier is. Now let's do the protected. Let's say I have this one, string address get set equal to 123 main street. Okay, now protected is like your family recipe. Okay, which is like within the family, it is accessible to everybody. What actually it means, that it means that within the class or its derived class. So if I come here, right, and if I say that, hey, my address is changed, so within class can access protected member, it is accessible. Okay, and let me do one thing. Let me create another class. Okay, uh, let's say something like smart house, and this smart house is a derived class of the house. Okay, and let's say public void change address. This is a typo. I can change this one as well. And if you see here, changing address to here, if I have something like 123, let's say Melbourne Street, let's say something like that. Okay, now first thing, if you see here, right, if you click on go to definition, it will go and it will start indicating the protected. Okay, so So if you see here, so what actually it means that derived class protected is accessible to derived class as well. Okay. And here, I mean, it's a clear demonstration. Okay. Now, derived class could be within the assembly or could be outside the assembly. If I move this code, Control C, and if I do like this, right? If I go here, so, and let's see if I do here, right? Still, you should be able to do that. Protected, you will still able to access it. The reason is the only rule is that within the class or within the derived class. And your derived class can exist anywhere. So I put it the derived class outside of the assembly. And if you see here, if I click on this one and if I click on go to definition, you will still able to redirect here. Okay. So we covered public, private, protected. Let's cover the internal. Okay. So let's say we have something like internal, and let's say we have this one internal int number of rooms get set. So so internal is like within the assembly itself, it is accessible everywhere. So if I do here something like uh number of rooms equal to 6, obviously, I mean, see, this method doesn't make sense ring doorbell, but this is just for demonstration purpose. So it is accessible within the assembly. If I go in a smart house, and if I, let's say, if I hear something like public class, let's say neighborhood, right? The reason why I'm putting neighborhood, because we are within the same assembly, right? And let's say if I have here, and if I do like number of rooms equal to 10, if I do here, right? And since it is a different class, obviously we will have to create a object of that house, house equal to new house, let's say we have here, right? And then if we do here, now see here, okay, so this is accessible as well. So it is internal. Okay, now let's try to access the outside of the assembly. So we have house object here. Okay, so we have house object here, and if we do here something like house dot number of rooms, okay, equal to 20. Now let's do that. Oh my bad, sorry about that. House, okay, now see here, house dot number of rooms is inaccessible due to its protection level. So now you see here, it is internal and we are outside of the assembly. So that is the reason you will not able to access it. Now let me comment it out, and then we will put one internal protected. Okay. Now if we have internal protected, and let's say internal protected, we have this one string on a name. Now if you folks see, I mean, we did internal int and we were not able to access outside of the assembly, but since we put it the protected, and protected, what it does, that within the assembly or any derived class, now we can utilize this derived class. If you declare a derived class within outside of assembly, you should be able to access it. So let's quickly, demonstrate this one. We will go in program and we will try to access here, okay? And number of, not number of gnomes. Let's say here, honor name equal to John Doe. Now look here, accessible honor name is internal protected. If I click on definition here, I should be able to do that. So now in this demo, we reviewed public, private, protected, internal protected. Now let's try to recap one more time just to understand. So one more time, let's go to this slide. Public, accessible everywhere, within the class, within the assembly, outside the assembly, doesn't matter. It is accessible everywhere. Private, only inside the same class where you declare it. Protected, it is accessible within the class or derived class. If derived class is exist within another assembly, you should be able to access it. Internal, within that assembly only. Okay, protected internal, within that assembly or through the child class. So that's the sum up of today's episode. If you like this content, please do subscribe. Drop a comment, any topic if you like me to cover. Thank you so much for watching.